Before we hand over to him, I've realised I've missed two important things. The first one is, please stay in this area, so don't go beyond the stairwell there, out here. If you need the bathroom, it is back through the lift lobby and out the back, out the door there. I don't know what the policy on drinks is at the moment. You had a policy.
Yes. Well, we're trying something out, which is soft drinks at the beginning. So if you haven't got a soft drink, there are more drinks there.
There's a big fridge full here.
And yes, a big fridge full. And then we'll have pizza after Uma's talk, and then we can.
And the beer fridge will be open. And there's a wall of snacks here when you have, if pizza's not enough.
Okay. All right. Thank you.
I will keep it short and let you eat pizza. So the title of this talk is Errata, Precision Error Handling in Functional Scala. But this talk isn't really about this library Errata, and it's not really about precision error handling. It's rather about adequate error handling. An alternative title for this talk is Applicative Error is the Wrong Trait to Have at the Base of Error Handling. I think maybe I should have run with that. If you take home one thing, that's the thing to take home. So a bit of background on why this bothers me. I've been programming since I was 12 years old. I've been doing functional programming for about 7 years, most of it in academia, doing proof engineering in Agda. I've been writing Scala for about 2-3 years. And I'm very sad to see services break at runtime because we forgot to handle our errors. So that's why it bothers me. So a bit on error handling. What is error handling? We want to model computations. We want to, sometimes something can go wrong with a computation. We want to model the category of things that can go wrong. And we want to be able to often recover from those things as well. And so basically, this is Java checked exceptions kind of thing. There are several ways to go about it. The most basic one is using data types for it. So a type where you have basically two branches, something like option or either, where you have the happy branch and you have the sad branch with your errors. And that's all well and good. The only thing is often we also want effects in our programs. And so we end up with this thing where we have the effect, and inside of the effect we have the data type modeling for errors. And inside of it we have the value that we want to obtain back. So we end up with this double nested structure that is quite difficult to navigate. The types get longer, the programs get longer. You can use mono transformers to handle them, but those are also a pain. So the good thing about this is that the compiler will actually check that at compile time you're handling your errors, because either has two branches, and when you case match against it, you will have to take care of both branches, including the errors. So that's the good thing of it. There's this other approach where you actually lift the error handling into the effect itself. This is very used in tagless final. In CATS, we use things based on applicative error, and this gets rid of this double nested structure. So your types are smaller, your programs are smaller. However, because of how applicative error is defined, you have no guarantees that you're actually handling your errors and your programs can break at runtime. Why? Because applicative error is the wrong trait to have at the base of error handling. And so let's have a look at it. Applicative error is a trait parameterized by the effect and your type of errors. And there's 3 things to note about it. One is it merges both raising errors and handling errors, so that's the first thing to note. 2, it extends applicative, that's the second thing to note. And 3, and this one I consider very important, when you handle your errors, you take an F in and you give the same F back out. And that has its consequences as well, as we will see. So those 3 things to notice. The consequence of the first one is, let's say you have this method that accepts an applicative error. You don't really know if this method, by the type signature, you don't really know if this method handles errors or raises errors or does both. I could say in the documentation, give me an f of a, and I will handle the errors and give you back. I think, okay. I will only handle errors. I won't raise any, but there's nothing. If you give me an applicative error, I could be raising errors as well. So there's nothing at the type level that guarantees that I will only handle errors. So that's the first bit. The second one is that, let's say we model our domain for errors, and we have different error types, E1, E2, and we want to be able to handle them both. So we accept two applicative errors, one on E1, the other one on E2. And that's all well and good, but because they both extend applicative, if we try to use that applicative instance, we get ambiguous instance compile time errors. And there's ways around it, but it's not good practice to have two instances in context. So what people end up doing is they have only one type of error throwable, and they extend all of these, their error types extend from this type throwable. And this is so common that there is an alias for it, which is applicative throw. And that works. However, the result of that is that you don't only have to handle the errors that you model in your application, you have to be able to handle every type of error. So anything that extends throwable, and of course, throwable is an open type, so it could be anything at all. And handle error with doesn't accept a partial function, so you need to do this every time. Now, the last consequence of having the same, if you remember, handle error with has the same, takes the same f in as it gives out. And as a consequence, let's say we want to define this function attempt, which promises in the documentation, I will capture all the errors in f, and I will put them in an either, and the resulting f will have no errors anymore. Well, you have to say it in the documentation because there's no way to say it at the type level. So here you could have errors in either, but the user of this function, because you end up with the same f, you're still able to raise and have errors in f. So basically, you don't keep track of the fact that you are handling errors at all. And so an example of that, let's say we have an I/O app, and it has two subsystems, and they both raise errors. First, we can't really model what type of errors they raise. They both have to raise errors of type throwable, so you can't really model at the macro level of your service what kind of errors each part of your service deals with. We also don't know those parts raise errors or handle errors. And lastly, you can forget to do any error handling at all, and this will compile just fine. The compiler will not guarantee that you handle your errors. If you run it, and this is perfectly valid code that compiles, if you run it, it will break at runtime. And this is horrible. So real life consequences, this has happened to me several times where I've deployed something on a Friday at 2 p.m. Everything seemed okay. That's when we did Friday deploys. And then 8 p.m. I receive a pager alert where things break, and it's because one service didn't do error handling, the other service that depended on it didn't do error handling at all, and they are stuck crashing in a loop. It also happened when I rewrote a service from this f of either style to this lifting the error into the effect style. This was a diff of like, I don't know, thousands of lines of code. So it's very easy to forget to do error handling if the compiler doesn't guarantee that you have to do it. And of course, I did forget in certain parts. And of course, it did blow up at runtime. And yeah, this is horrible. So I went on the internet and searched for like, what do people, like surely there has to be a better way to go about this. And I did find some very interesting notions in this library called Tofu, which is a library for functional programming. I created a library based on some of those notions and added some other things. And this is the library called ratam. So it solves all the problems mentioned so far. It's fully CATS compatible, but the goal is for it not to exist. So the goal is instead to make changes to CATS. However, you can already use it and you can already benefit from it. You can use it to prevent these runtime errors. And so the essence of it is these two changes. So instead of having this applicative error definition, we have this definition where we have one trait for both, but we have two traits. One is concerned purely with raising errors. The other one is concerned with handling errors. Neither of them extends applicative. If you want an applicative instance, you ask for one. And lastly, you'll see the handle to accept one effect as a parameter, it accepts two effects. And when you handle errors, you go from the F to the G. And that allows you to keep track at the type level that you are handling your errors. And there's some other aliases, basically, so these are the most precise types you can use, but you don't have to use them. You can be a bit less precise. And so there are aliases for a bunch of things. An interesting one is transform to, for example, where you go from having errors of type E1 in an effect F to having errors of type E2 in an effect G. And so let's have a look at how this solves the issues presented so far. For starters, in this example, you'll see a consumer, you'll see a producer. The producer can only raise errors. It accepts a raise instance, and the consumer can only handle errors. So the consumer here can't at all raise any errors whatsoever. It's impossible for it to raise errors. And then when you put them in touch, when in this process method down there, when you put them in touch, you need to, of course, know how to do both raising errors and handling errors. Here, let's say we have our domain-specific error types, and we have two producers. One raises errors of type client error, the other one raises errors of type database error. In the consumer, you know how to handle them both, and you'll see that you don't have to handle every error of type. You only need to handle your errors of your application. And then, yeah, then you put them in touch. And lastly, that you're handling errors is reflected at the type level. So in this definition of an alternative attempt, you'll see that we accept an F of A, and we give back a G of either. So we say, I will handle all the errors in F. In G, there will be no errors left, and all those errors will be in the either. So here, it's impossible in the resulting G to have any errors. So you're making sure at the type level that you're handling all of them. And if you were to leave it out, the error handling, you would get a compile time error. It has some other features. So it has some convenient syntax on effect types and error types. It has instances for common data types like option, either, etc. It's full interoperability with CATS. And also, if you define your own instances, you can automatically check that they pass the algebraic laws that they are meant to comply with. And the essence of it is that I want to, instead of having applicative error be one definition in CATS, I want to split it into the sum of raising errors, handling errors, and applicative. So if you want more precision, you can use this sub. If you want less precision, if you want less precision, you can still stick with applicative error. And it has full interoperability with CATS. So if you have at the top of your application, if you have I/O, let's say you want to use errata for your application logic, you can derive this errors instance that knows how to handle errors and erasers. And basically, it has a translation layer that wraps things up when it goes into CATS and unwraps things when it goes into ratam. And the solution with the interoperability on downwards, let's say you have your errata application, but you want to use an HTTP client that is, of course, based on CATS. The solution for that, the solution I propose for that, is basically dependency injection. So you create your HTTP client at the very outer level of your application, and then errata doesn't need to know the fact that it needs a monad throw, for example, to exist. So this is an example of all of it coming together. It's a bit verbose, but so at the bottom we have our I/O app, where we carve out this errata instance for handling errors. At the top there, we have the HTTP client, which receives the CATS monad throw injected. And then in the app logic, you'll see this is overly precise, but it's just as an example. Instead of there being one effect, there's 3 effects, F, G, and H. And we accept a transform to instance, which transforms effects of type throwable in F into effects of type app error in G. So this is, we create our application specific, domain specific errors. And then we also demand an instance that say, I handle all the errors of type app error in G, and there's no errors left in H. And the return type of this app logic method is H. So by the types alone, we can see that there's no way we could forget to handle errors in our application. So this is basically it. There's a bunch of questions I have about it, which is what's the story with CATS effect? How do we integrate with that? What's the story with FS2 streams? And then a bunch of I have for you. Do you see error handling in CATS being, I guess, deficient? As in, like, could it be better? Do you think it could be better? Would you find something that is valuable? Would you use something like this? And would you want to help change things in CATS? Lastly, maybe the most important one, am I missing something? And yeah, that's basically the talk. This is a summary of it. I'm open to work, and yeah, that's how you can get in touch if you'd like to. Thank you.
Cool stuff. Right, any questions?
Hello, hi. Can you hear me? Yeah. So with a lot of teams moving from tankless funnels to using concrete I/O or even for testing, is there plan to also, or do you already have some extensions for I/O or to bake this kind of methods in I/O without calling the...
Sorry.
Sorry?
Could you repeat the question again?
So with a lot of teams moving away from tankless funnel and using concrete I/O, is there any, you have any plans, or is it already in the...
As in, like, using direct style, or...
Yeah, like maybe extend I/O or add some methods there so that you can pull those new functionality from Rails. And
I think, so there is a very similar library with similar ideas. I forgot the name, I should know it. But it's basically based on this, like, direct, instead of tackless final, this, what do we call it? The direct style approach.
like I/O.
I/O.
So it's using the type I/O.
Is there a movement to go back to I/O?
I think so, yeah.
That
Regardless if we are
horrifies
a
me.
hobby or, yeah, regardless if we like it or not, I think.
Okay, I
or even
didn't know
for the
about it.
testing, for tests and stuff, people are more using I/O now instead of
Mono-transformers and for testing, I could see it, and I mean this should work perfectly fine with just using I/O. There's not much of a point to it if we go all the way back to we want our types to be the least precise as possible. Like we want like the capability to launch nuclear missiles, then there isn't much point to it. I'm very opposed to that movement, but yeah, I think in the presence of just using I/O, nothing of this would make sense. So I would disregard all of this, basically. Yeah.
Any more questions?
So I admit that I haven't used applicative error much anyway, but one thing that's interesting about applicatives is that you don't necessarily just have to have one error. You can have an error coming from one side of a computation and another, and it'd be nice if those can be basically collated. So instead of handling them in one place, you can say, right, I want to bubble up a bunch of them and report
accumulating
them later.
errors.
Yes,
Yeah.
exactly. Is that something that can be handled with this as well?
Totally.
Cool.
Yes. I don't see why not. So there's this. Oh gosh. Sorry. In particular, relevant to that, there's this transform to definition, which basically allows you to transform errors of type E1 in F into errors of type E2 in G. And that could be very well used to do this accumulation effect. Right. So basically E2 would be a list or something of that sort, and you would basically accumulate your errors there. So yeah, it's perfectly possible, yes.
Okay, cool.
You more, one question, right? Keep me moving, right? Get my steps in.
Hello. Have you been on the type level Discord, and if so, what's the reception been in there?
Not on the type level Discord, no. I've been a bit too scared to go on there yet. But the idea is that my intention was to do so, yes. So at some point I need to ask more people. This is my first bunch of people I asked to. So I need to ask more people if like, do you think there's something in this? Like, is there a point to this? So yeah, the talk is more about like, do you see some usefulness in this? Because I don't want my services to crash at runtime, and I think this would help me avoid that.
Cool. I think we all believe in not crashing at runtime.
Yeah.
Right, any more questions? Yes.
Hello,
Sorry.
Becky.
Hello.
Hi.
Did you have to make any trade-offs when you made this library, or do you have like any known cons?
I think then the one trade-off is the interoperability with CATS, where we do this wrapping and unwrapping. It's based on class tags, which are horrible, and also because of it, you can't really, you need to have concrete types, and you can't have types with type parameters in them, because class tags don't really distinguish between them. So I would like to rewrite that part of the compatibility layer and maybe use Scala 3. So this is, you can use this for both Scala 2 and Scala 3, but maybe it makes sense to use the macro goodies that we get in Scala 3 to do this instead of using class tag. So I think that's the only drawback to this, the wrapping and wrapping. But if it were to be integrated in CATS, nothing of that would be necessary. So there would be no wrapping and unwrapping. Yeah.
Is it used in production at all?
Yes, in fact, we do use it at one of our services in ITV called Chandler. And yeah, it's very much a service that takes things in from a Kafka queue and throws them out into a bunch of different like S3 buckets or a bunch of different things. And each of these target system has a different set of errors that can be raised. And so it's very useful to model that. Yeah.
Thanks.
Thanks.
What do you feel are like the pros and cons of using like the either left channel to handle your errors versus your library?
Yeah. Well, I guess they either, so it would be the same pros cons you would have between using either and using applicative error. So when you use either, that's all well and good. You do get compile time checking that you handle your errors. However, you have this nested types, the F, the effect, the either. And so you end up with big programs and big types and monad transformers. And so the code gets very verbose very quickly. I do, in some ways, prefer this approach than using applicative error. When I rewrote this service from this either approach to this F with applicative throw approach, it was painful to do it because I didn't really believe in that change. So the programs got shorter, but also the service started crashing. So I would rather have longer programs and more robust services rather than shorter ones and more finicky services. And I guess this approach, the one I'm proposing, is really the best of both. So you would get shorter programs, shorter types, but you would get compile time checks that you're handling your errors. Yeah.
Thank you.
Why do we keep moving from the front to the back every time someone asks a question? If only there was a stack of microphones, Zainab. If only.
So just out of interest, how does this play with, like, if instead of resource allocation, instead of error handling, what you want to do is resource allocation? So like you allocated something, like opened a file, you don't want to handle the error, but you want to make sure that you take some action, either like in the error case and the success case.
So repeat that last part, sorry.
So you want to do like some cleanup action that you do in the error case or the success case, but you're not getting rid of the error. It wasn't obvious to me from the type classes that you showed how you'd write that.
So I didn't really understand the. So you're saying how does this work with resource allocation, and what was the like deeper question, the more concrete question?
I think just from your type class list, it wasn't clear to me like how you've opened a file, you want to close it once you've done a thing with that file, and you want to do that whether or not you've errored, but your error case is still you still want to propagate your errors. You don't.
Yeah, I don't know. I would have to think about that. Interesting question. I can't tell you off the top of my head, but hopefully that's work together. Yeah.
Cool.
Sorry.
Any more questions? No? Well, I think a big round of applause for Uma.
Thanks.
Then.
Thank you.